So, onto the arrow. Aristotle says that all Zeno's paradoxes, denying the possibility of motion, present problems to those who try to solve them. And I think we're going to find this is particularly true about the arrow. So, according to Aristotle, Zeno claims that the flying arrow is at rest. Notice just how paradoxical this is. The arrow's already got to be in motion. It's got to be flying for the paradox to work. If you said the motionless arrow is motionless, that's not a paradox. It's the fact it's the flying arrow is at rest. That's what makes this so particularly tricky. Now, Aristotle says that this only works, the paradox only works, he claims, if you regard time as composed of nows. In the Greek, ek ton nun, nun being the word for now. And that if you don't regard time like this, the paradox doesn't follow. So we're going to first of all construct our paradox, but then we're going to have to ask, do we have to regard time as composed of nows? What does now, nun, mean in the Greek anyway? But first, let's see how Zeno constructed this arrow paradox, at least as according to Aristotle. And don't forget, we don't have Zeno's book of 40 paradoxes. We just have a few of them paraphrased, interpreted, outlined, we don't quite know what, in later writers such as Aristotle. So first of all, premise one, anything occupying a place just its own size is at rest. Premise two, in the present, in the now, the nun, what is moving occupies a place just its own size. So, three, in the present, what is moving is at rest. But four, what is moving always moves in the present. So five, conclusion, what is moving is always, throughout its movement, at rest. Okay, so the claim is that everything is at rest for any temporal interval during which it occupies a place equal to itself. But one might counter, this is only true if the thing in question, say the arrow, occupies the same place for that stretch of time. And the moving arrow clearly doesn't do this. It does not occupy the same place for that stretch of time. But what if time were not infinitely divisible, as in the dichotomy and Achilles and the tortoise, but finitely divisible into indivisible minima, indivisible chunks? Wouldn't the arrow then be trapped in one indivisible chunk of time, and therefore in the same place for this indivisible chunk, and therefore motionless? And if you're meant to regard the entire flight of the arrow as composed of these indivisible chunks, then the arrow would be motionless throughout its flight, just as Zeno claims. So problems arise if we think of time as composed of nows, as periods with a dimension, as tiny indivisible chunks of time. So let's suppose that time is, after all, infinitely divisible, and that now refers to a moment, a dimensionless instant. Now, at first glance, this would seem to give us a way out, as we can say, okay, admittedly, you can't tell whether the arrow is moving or not moving at any one dimensionless moment, because you would need reference to at least two dimensionless moments to work out whether the arrow has moved. But this does not mean that you can say that the arrow is not moving throughout its flight, because the flight is not composed of a series of dimensionless moments. No stretch of time is composed of a series of moments any more than a line in space is composed of its dimensionless points. This looks more promising. We've got the moving arrow moving again. But we still have a huge problem on our hands, and it concerns the nature of time. Because when exactly does the moving arrow move if the present, the now, is simply a dimensionless moment? What is the present? If it's simply a dimensionless dividing line between past and future, when does the arrow possibly move? Maybe we can only ever say that the arrow has moved and not that it is moving now. So problems arise with the arrow paradox whether we think of time as finitely or infinitely divisible. And if time exists, it must be one or the other. So maybe time doesn't exist, just as Zeno's master Parmenides had originally claimed.